talk about logarithmic functions. And so, first of all, we need to define what a logarithmic function is. And so a logarithmic function with base b, okay, is defined as being y equals log base b of x. B is a subscript here, small, okay, if and only if b to the y equals x. Okay, now that's something you're going to want to file away to memory. Now, I don't expect you to memorize it per se, because we can actually derive what that is. And so if I start with y equals log base b of x, there is a way that I can derive b to the y equals x from that. Okay? One of the ways that we can undo a log base b here is what we're going to do is we're going to place base b on both the left side and the right side. You know how when we add to undo addition we subtract? When we undo multiplication we divide? When we undo squaring we take the square root? Well, when we undo a log, we take whatever the base is and we're going to raise both sides to that. And so on the left side, you are left with b to the y. On the right side, what ends up happening, since b and log base b are inverse operations, they cancel each other out. Kind of like addition and subtraction do, multiplication and division. And so I'm left with y. And if you notice, that matches up with this right here. Now a little bit about x and b. X has to be greater than 0, b has to be greater than 0, and b cannot equal 1. Now for those of you kind of wondering, what is b? B is any number. It can be 2, 3, 4, 5, 6, 7, 8, 9, or 10. On your calculator though, the only thing you can do is log base 10. Reason being, we are in a base 10 number system. We have 10 different digits, 0 to 9. Okay, everything in our number system is based on 10. If I have log base 3 here, you can't do that on your calculator. Log base 3 means there are only 3 numbers. So log base 3 would have the numbers 0, 1, and 2. So those would be the only numbers you would use. Log base 4 would be 0, 1, 2, 3. So it would be 4 numbers. Okay, log base 2 has how many numbers? 2, 0, and 1. And that's called the binary system, and that's what computer programming kind of was founded on. Okay? So I had a bunch of zeros and ones on there. So anyway, where are logarithms used? They're used a ton of places. In Haiti, when I created this, Haiti had just had a major earthquake. Okay? And logarithms are used in determining the level on the Richter scale that the earthquake will be classified as. Okay, that formula actually has a logarithm in it. Science, they're used in acids and bases a lot. Okay, a lot of those formulas deal with log, you'll see that. Money, we dealt with that a little bit yesterday, and you'll deal with that a little bit more. Used in interest, annuities, use logarithms in their formulas. Music and sound is used in decibel levels. Okay, and then climatology, it's used in determining like the jet stream, things like that. Those equations have logarithms as well. So now, we're going to go ahead and look at the basic properties of logarithms. So you need to go ahead and get these down. The basic properties of logarithms, there are 4 of them. Okay? So if b is greater than 0, b cannot equal 1, and x is a real number, then the following statements are true. I'll let you go ahead and get those down, and then we'll talk about them. Okay, so the very first one, the log of any base. Okay? If you take the log of 1, it's going to be 0. That's just kind of one of those things to file away. So log of any base of 1 is 0. Log base b, why does that equal 1? Well, that's kind of like what we talked about. Earlier. And what we talked about earlier is that log base b and b cancel each other out. So since this power is 1,
Grab the ink.
they cancel. And so we'll see if I can grab another pen since we're having trouble with that one. Okay, so what ends up happening is then the log base b and b cancels out, and that leaves you with 1. On the next one, once again, log base b of b cancels, and that gives you x, so whatever number that is. And on this one, those cancel, and that gives me x. So that's the biggest thing what I want you to take from today is that if you have a base and then the log of the same base, those cancel each other out. And so let's go ahead and look at the next one. It says to evaluate each logarithm. So if you notice here, I want to do log base 3 of 81, and as I said, your calculator won't do these. So what we need to do first of all is we need to focus on 81. And what I need to do is look at the base. The base in this problem is what? 3. So I need to think, how can I write 81 as a power of 3? And so on your calculator, you can do this just trial and error. 3 times 3 times 3 times 3 to get to the power that will equal 81. And what power of 3 will equal 81? 4. Okay? So then now in looking at that, what do you know your answer is going to be?
4.
4, because those cancel, and that's going to leave you with 4. So see, the whole purpose of us writing that with a base of 3 is so we could cancel it out. So let's look at the next one. Okay, once again, I'm focusing on this number right here. And I want to write this number as a power of what? 5, because I want to cancel it out. So I've got log base 5 of 5, and I need to think, how can I write the square root of 5 as a power of 5? 5 to what power? 1/2, right? The square root is the 1/2 power. That is what it is defined to be. And so now, what is your final answer going to be? 1/2, because those cancel.
It always gonna be this.
What?
It always gonna work like this.
Pretty much. Let's look at the next one. Once again, what am I going to look at first? The 149. That is the number I'm concerned with. And I need to figure out a way to write 1/49 as a power of what? 7. And so when I think about 49, I know that that's 7 squared. But now I've got a problem. And what's the problem? The fraction, the 1. So I have to figure out a way. Is there a way I can get rid of that fraction? Ideas? Yep, 7 to the negative second. Remember, the negative means I've got a fraction. Okay, the negative flips wherever it belongs, and so since it's on the bottom, if I move it up to the top, that becomes a -2. And my answer to this problem then is -2, since the log base 7 and 7 cancel.
Isn't that one just 0?
1, because
yeah,
remember
one.
this is 2 to the first, so then they cancel, leaves you with 1. All right. Oh, skipped one, let's go back. There we go. So far, we're on, I think, the 5th problem, so we're moving fairly fast, you can see. What's my answer going to be here? 3.2. Good. It's 3.2 because log base 4 and 4 cancel. Now remember, our whole goal was to focus on the root 2. And I have to think if there's a way I can write 2 as a power of 16. So I'm going to show you something a little different. What do you know about the 2? It's a square root, right? So how can I write that?
It is.
1/2.
Yep, so basically I've got log base 16 of 2 to the 1/2. Now what I'm going to do is something a little different. It's kind of unconventional, but it'll work, and it's probably the easiest way for you to understand this problem. I'm going to set it equal to x. I'm just going to make it equal to an equation. And I'm going to write this equation so that the log is gone. So how can I get rid of that log? Yeah, 16. And I'm technically not timesing it, but what I'm doing is I'm putting the base there and then I'm making everything else an exponent. Whole purpose in doing that is that on the left side, I'm left with 2 to the 1/2. On the right side, I have 16 to the x. Now this problem is a little more workable because I now have a base of 2 and a base of 16. What do I know about 16, this number here?
It's even.
Keep going.
That's
It's what? It's 2 to the what? 4th. Good. It's 2 to the 4th. Okay, so 16 is 2 to the 4th. So the whole purpose in doing this is now I can write them with the same base. They both have a base of 2. And when I now apply a power, or a rule of exponents, I know that this is really 4x. Remember, you can multiply those if you have a power to a power. can somebody guess what my next step will be? Yeah, and so really what am I left with? 1/2 equals 4x, okay? Remember, if I have the same base here with base 2, the exponents have to be the same. And so all I'm going to do is set them equal to each other. And so in order to solve that for x, what do? Divide by 4. Another way to divide by 4, since we're dealing with fractions, is to multiply by 1/4. So your answer is 1/8. Now, converting this to an equation, we will actually get to solving equations in the next section, section 3. Okay, and so this is one thing that if you kind of start here, it's going to give you a little head start there. You shouldn't have very many of those that you need to use this on. Okay, let's look at one more before we talk about something else. Okay. What's my answer here? 1. There you go. Because the 3 and the log 3 cancel, and it leaves you with 1. All right, so now what we're going to do is, if you remember I said we're going to talk about something else, and we're going to talk about something known as the common logarithm. The common logarithm is the logarithm you can do on your calculator. And that's the logarithm with base 10 or log 10. So if we have a logarithm with base 10 or log base 10, now you're also going to see this written with no base. So if you ever have no base written, so you just see the word log and then a number, it's always implied to be base 10. So it's always implied to be the one that you can use with your calculator. However, I'm not going to want you to use your calculator on this, and I'm going to expect some work shown. Now we have 4 basic properties of common logs. And basically, these are the same as the first 4 you wrote down, except for they're written in terms of 10. So it's implied that 10 is the number on each of these. And so that should make sense. Remember, we talked about the log of any base of the number 1 is 0. Log base 10 of 10 to the first power. Remember, those cancel. They cancel here, and they cancel here. And so all the properties hold true. They're still the same, regardless of if it's the common logarithm or if it's a regular logarithm. So now what we're going to do to finish up today is we're going to look at a few examples of a common logarithm. And then we're going to let you go on your assignment. And then tomorrow Monday we'll finish dealing with this section. We're going to talk about natural logarithms. So let's go ahead and look at a problem. It says to evaluate each expression, and no, you can't just type this in on your calculator. You're going to have to show me some evidence of work, especially on your quizzes and tests. So it says log of 0.001. So first of all, we know it's log base 10. So what I need to do is I need to think about how can I write 0.001 as a power of 10. So that is really log of 1/1000. Okay, because that's what it is. It's 1/1000. And we know that 1/1000 is really 1 over 10 cubed. And I know that how I move my 10 cubed up is I make it negative. So my answer is -3. Now, some of you might be able to do some of those steps in your head. That's fine. On the next one, what is your answer going to be? 5. Because those are going to cancel, leaves you with 5. So far, so good? We've got a few more to look at. There we go. Log of 10,000. So in other words, we have to write 10,000 as a power of 10. The easy way to do this, okay, before a lot of you start feverishly typing in on your calculator, all the exponent is going to be is the number of zeros that you have. So how many zeros are in 10,000? 4. So really, this is nothing more than 10 to the 4th power. So your answer then is 4. What do you do on this next one? Yeah, it's 81 over 1,000. Is there? Yeah, it's 81 over 10 cubed. What is it on your calculator when you type it in? Is it negative 1.09? Oh, it is negative 1.0915.
Yeah.
Okay? The only way that you can do that as of right now is to just use your calculator on that one. We will eventually talk about how you can add and subtract logarithms and get a more precise answer than that. Okay, now a little bit about today's assignment. Okay, this is also the assignment that's going to be given on Monday. I might add a few problems. Now on 1 through 24, if you want to go ahead and turn in your book to page 178. If you go ahead and turn in your book to page 178, you're going to notice that on number 11, what do you notice? Actually, not number 11, number 12, what do you notice? It's got an ln and an e. We haven't talked about the natural logarithm. We're going to talk about that on Monday. Okay, and so what's going to happen is whenever you see an ln or an e in the problem, okay, so like 12, 13, 14, 16, 18, 19, 20, 21, and 23, you're not going to be able to do those. And that's okay. If you want to read up on it and look at it and go ahead and do those, that's fine. It's actually fairly easy. But you're not going to be able to do those. You'll have to add those Monday. And like I said, I'll probably add a few problems Monday as well. But you need to work on 1 through 24 for Monday.